They called it Bulletproof. A cast iron beast that shrugged off abuse, crossed continents, and built trucking empires, giving fleets a nearly $1 million advantage annually. But just when it seemed unstoppable, it vanished. What could have brought this Cummins legend to its knees? The war had ended and America's freight business was booming. The post-war economy needed diesel power strong enough to turn military logistics into peacetime profit. Cummins began evolving its reliable Model H after the war, introducing the improved New Head, NH series. These updates reflected lessons learned during wartime production and logistics, with NH appearing on build plates as the series designation. At first glance, it looked like a familiar tall inline six cast from gray iron, but inside, everything was improved. The original Model H featured a 4.87 5-inch bore and 6-inch stroke, totaling 672 cubic inches. While the immediate post-war NH retained the original bore and stroke, later NH and NT series engines introduced in the 1960s and 70s featured increased displacement for even greater power. A major innovation came in 1958 with the NH-180, which featured increased power output and refinements to its 2-valve per cylinder head, setting the stage for later advancements like the 4-valve big cam heads introduced in the 1970s. This boosted airflow, cleaned up combustion, and pushed rated power up to 200 horsepower at 2100 RPM, significantly more than the original Model H, especially when combined with turbocharging. Durability was non-negotiable. Wet liners meant mechanics could rebuild these engines anywhere, from barns to back roads. The forged crankshaft spun on oversized tri-metal bearings, and oil pressure flowed in torrents, not dribbles. Plessy Cummins was famous for cross-country demonstration runs in the 1930s, showcasing the fuel economy of Cummins diesels compared to gasoline trucks. The timing couldn't have been better. Wartime diesel expertise and surplus alloy met a civilian economy desperate for hauling power. Kenworth, White, and International signed OEM deals to drop NH powertrains under fresh paint, just as the interstate system was beginning to reshape America. Freight rates tightened, and fleets wanted more ton miles per gallon. Cummins delivered exactly that. Meanwhile, the noisy Detroit diesel 2-stroke 671 and thirsty Hall-Scott gas monsters suddenly looked outdated. By the early 1950s, the NH was rapidly gaining ground in the diesel trucking market, and its continued innovations, such as the later 4-valve head, helped cement its legacy as a blueprint for rivals. The block was built to last. Heavy-duty cast iron with thick walls and wet sleeves that could be replaced in the field if needed. The forged crankshaft rode on large bearings, contributing to legendary durability. Oil pressure was robust, typically running 15 to 30 psi at idle and climbing to 60 to 80 psi under load. The oil film was thick enough to keep everything well lubricated. Serviceability was a key design point. The NH series used 3 paired cylinder heads, each covering 2 cylinders. So if a gasket failed, a mechanic could remove just one section for repairs, a significant advantage over single-piece head designs. Most NH and NT engines used 2 valves per cylinder. 4-valve per cylinder heads appeared only with the later Big Cam series in the 1970s. All were driven by robust rocker gear. Early NH engines were naturally aspirated, but turbocharged versions appeared by the late 1950s and early 1960s, further boosting performance and efficiency. Fuel delivery was elegantly simple. Cummins' pressure time, PT system, used a gear-driven pump to build fuel pressure, while cam-timed injectors controlled the spray. No delicate racks, fewer wear points, and the system self-adjusted as parts aged. A driver with a couple of shims, a dial indicator, and some patience could recalibrate at roadside. Accessory mounting was straightforward, making service and repairs relatively easy for mechanics. Valve lash was set with a feeler gauge, not firmware. Turbochargers used on NT engines were known for their robust journal bearings and durable housings, contributing to reliability and ease of service. Torque was king. Peak torque on NH and NT engines arrived at relatively low engine speeds, often below 1600 RPM, allowing drivers to lug the engine, save fuel, and reduce valve train stress. Keep it cool. Change oil every 10,000 miles. Adjust injectors at 100,000. And you had a simple, effective playbook. Even the ancillaries were oversized. A gear-driven oil pump and high-capacity water pump ensured strong lubrication and cooling, even in demanding conditions. Fuel ran through internal galleries designed to avoid cracks from vibration. Injector settings could be adjusted relatively quickly, and with proper maintenance, the system remained reliable for many miles. High-strength bolts and standardized fasteners made roadside repairs more manageable. Fleets told stories of NH blocks finishing contracts installed in second chassis, or logging over 1 million miles before their first major overhaul. Where others shaved ounces, Cummins cast iron. The result? An engine that the industry simply called bulletproof. When Cummins rolled out the NH, it delivered a solid 150 to 175 horsepower, enough for the two-lane roads of the time. But as trailers got heavier and delivery deadlines tightened, more power was needed. Cummins experimented with turbocharging and increased fuel delivery. Higher output variants pushed the limits of the NH's bottom end, but true 300 horsepower ratings became common only with later turbocharged models. A cleaner, more efficient fix arrived in the late 1950s with the introduction of turbocharging on the NH series. The NT262 packed 262 horsepower, with better fuel economy and altitude performance. Engineers kept pushing. By the early 1960s, production NT engines such as the NTC335 hit 335 horsepower without excessive smoke. Displacement followed. In the early 60s, Cummins increased the block's displacement to 855 cubic inches. Naturally aspirated output rose to around 230 to 250 horsepower depending on the application, but turbos stole the show. The late 60s NTC 335 became a fleet staple, and the 1970s brought after-cooled models like the NTA 370, which pushed denser air into the cylinders. By the mid-1970s, the NTA 400 shattered the 400 horsepower barrier, turning heavy doubles into highway sprinters. The late 70s and early 80s brought emissions and fuel economy challenges. Instead of just making bigger engines, Cummins refined what they had. The big cam era, starting in 1976, brought wider cam lobes, pulse-tuned exhaust manifolds, and demand flow cooling. Big Cam 1 offered ratings starting around 290 horsepower. Big Cam 2 passed 350. Big Cam 3 hit 400. And Big Cam 4 reached up to 475 horsepower in some ratings. All while sipping less diesel and pushing less smoke. Same block, just breathing sharper. Electronics arrived in 1990 with the N14, which used select electronic controls. Later, red-top versions pushed ratings up to 525 horsepower and 1,650 pound-feet of torque. The loudest, representing the peak of a design lineage that began decades earlier. The power translated directly to the bottom line. Freightliners with NTA 400s shaved an hour off Chicago to St. Louis runs, burning the same fuel as older 335s. Big Cam 3's pulse manifold boosted mid-range torque, making it easier for drivers to handle steep grades like Eisenhower Pass. Select adjusted timing on the fly, held cruise within 2 RPM ticks, and displayed diagnostic codes on compact in-cab screens. Fleets running the 525 horsepower red top, re-geared for taller gears, cruising at 1,300 RPM, cut fuel bills by 10%. And despite the power jump, reliability stayed rock solid. From 150 to 525 horsepower, the NH, NT, and N14 took trucking from gravel roads to 70-mile-per-hour interstates, thanks to smooth, straight six balance, robust construction, and, in the most advanced versions, 4 valves per cylinder. The crankshaft never flinched. By 1955, Cummins powered nearly half of all heavy trucks in the U.S., a dominance built on torque, fuel savings, and uptime. The coming interstate highway system demanded engines that could run long distances between stops, and the NH-NT delivered, achieving 5 to 8 miles per gallon, while gasoline rigs often struggled to reach 3 to 4 miles per gallon. Fleet accountants crunched the numbers. A 1956 Consolidated Freightways study pegged the cost per ton-mile for an NH tractor at 6.4 cents versus 9.1 cents for the best gasoline V8. Roadway, Yellow, and ABF rapidly adopted Cummins engines across much of their fleets. Dispatchers loved the dependability. Swap a spare filter Monday, and the Cummins rig was pulling into Omaha by Wednesday. Schedule intact. OEMs raced to show off Cummins power. Kenworth brochures shouted, "Cummins Diesel." Peterbilt's 351 came standard with the NH220, and later models like the 359 and 379 offered options, such as the NTC 335. International Harvester's Transtar boasted cruise power, while White, Autocar, and Diamond T bowed to customer demand. Even Greyhound tucked NH engines in the back to keep coast-to-coast schedules honest. Drivers cemented the cult. An NH220 climbed the Rockies in 4th gear, downshifted once on Vail Pass, crested at 35 miles per hour, and kept rolling. Odometers passed 1 million miles, and tales of NH blocks lasting through multiple chassis swaps became legend. In 1952, an NH-powered truck ran 13,535 miles non-stop at Indianapolis Motor Speedway, proving downtime was nearly a myth.
At the time, it was a truck engine. It wasn't even derived from sort of a passenger car engine. It was a truck engine.
A nationwide network of parts depots kept injectors and PT pumps available quickly, often within 24 hours. Canadian drivers praised the engine's reliable starts in minus 20-degree temps. The NH-NT didn't just dominate, it rewrote the American long-haul trucking business. When civilian work wrapped up, Cummins engines kept running strong in the military. The U.S. Army's NHC-250-powered huge M809 trucks, serving from the early 70s through the 80s and into Desert Storm. Even in dusty sand that clogged air filters or cold conditions that could thicken diesel fuel, the 855 cubic inch inline 6 churned out 240 horsepower, hauling bridge pontoons, howitzers, and wreckers without missing a beat. Simplicity was key. 1 fuel pump, 1 injector type, 1 gasket kit worldwide. Field motor pools swapped cylinder heads with a chain hoist, sealed engines before dawn, and kept convoys moving. Industry trusted the same reliability. Along Alaska's Trans Pipeline, skid-mounted NT-855 generators reliably produced several hundred kilowatts, powering operations through freezing cold blizzards. Texas oil rigs ran twin NTA 400s for extended periods, shutting down only for scheduled maintenance or severe weather. On the prairies, Steiger, Versatile, and Big Bud tractors often used Cummins N-Series engines, powering heavy-duty farm equipment through tough soil conditions. Custom harvesters logged 4,000-hour seasons with routine maintenance, focused on oil changes and filter replacements. Water was no problem either. Cummins Marine's NT-855M powered harbor tugs and shrimp boats, cruising at about 9 knots and consuming roughly 6 gallons per hour, with overhaul intervals up to 10,000 hours under ideal conditions. Municipal pumps, irrigation pivots, snowblowers, all shared parts and kept working. Even today, surplus NHC 250s fire up after years in storage. Just a fresh battery, functioning intake air heaters, and faith in cast iron bring them roaring back. Fleet accountants valued hard numbers. Let's track three 350 horsepower tractors over 500,000 miles of identical highway work. The 1980 Kenworth with a Cummins NTC 350 averaged 5.5 to 6 miles per gallon, burning about $98,000 in fuel. A newer Freightliner with Detroit's Series 60, introduced in 1987, could hit around 6.4 miles per gallon under ideal conditions, costing about $95,000. But the fuel gap narrowed once you factor in rebuild costs. Detroit's overhead cam rebuild runs about $12,000 in parts and 40-plus shop hours, while Cummins' in-frame rebuild kit, liners, pistons, bearings, and gaskets, averages $8,900 and 36 hours of labor. A Peterbilt powered by Caterpillar's 3406B averaged 5.5 to 5.7 miles per gallon, burning just over $105,000 in fuel, with the costliest rebuild around $15,000 and nearly 2 full days of labor. Downtime widens the gap. Shop idle costs about $800 a day in lost revenue. Over 500,000 miles, the Cummins rig spends roughly 5.5 days off the road, Detroit 9 days, and Cat 11. That's 18 extra paying loads for Cummins. Retiring after 7 years, Cummins trucks often command a 12% resale premium. Insurance data suggests they're slightly less likely to suffer catastrophic failures, saving on premiums. Lower overhaul costs, less downtime, higher resale, and cheaper insurance add up. Cummins rigs finish about $20,000 a head per rig, nearly $1 million edge across 50 trucks. Veteran mechanics would share stories about the Cummins engines. One Nebraska fleet reportedly rebuilt an NH 220 on a dirt floor at 600,000 miles, then ran it through 3 cabovers to 1.6 million miles, an extraordinary example of the block's durability. A Colorado hauler lost every gearbox tooth on Vail Pass, used the engine as a compression brake, and rolled into Denver with the crankshaft reportedly undamaged. Cummins built confidence early, offering extended warranties in the 1940s. Some reported up to 100,000 miles, although they were typically based on time and not miles. Reality outpaced promises. These engines regularly topped 1 million miles on original bottom ends. Fleets treated rebuilds as planned capital rotation, not emergency fixes. Why was it so durable? Peak torque hits near 1,300 RPM, so drivers lugged hard without engine-damaging grenade detonations. Oil lubrication kept piston crowns and bearings well protected with a thick oil film. Abuse met mercy. A Minnesota snowplow idled 12 hours after a fan belt snapped. Coolant at 250 degrees Fahrenheit. Teardown showed only warped seats. Roadside fixes stayed simple. PT injectors clamped in with 2 screws. Timing adjusted with color-coded shims. The 3-head design let a cherry picker lift ahead, swap gaskets, and keep rolling. Filters were stocked at truck stops, liners at farm co-ops, parts everywhere. The PT fuel pumps could compensate for some internal wear by delivering more fuel as clearances grew, masking minor issues that would sideline rivals. Drivers joked the only way to kill a Cummins was starvation, and even then, it might limp to the next way station on sheer willpower. In 1994, the EPA cut particulate limits and set a nitrogen oxide standard of 5 grams per brake horsepower hour. In 1998, the combined NOx plus NMHC limit dropped to 4 grams per brake horsepower hour. Cummins responded by upgrading the N14 Plus with smarter select electronic controls, but its 2-valve head and aging coolant system were struggling. New 2004-7 emissions rules demanded exhaust gas recirculation, EGR plumbing, and particulate filters the old 855 block couldn't handle. Retrofitting led to cavitating liners and clogged coolant passages. Cost pushed Cummins to design fresh engines. Competitors didn't wait. Detroit Diesel's overhead cam Series 60 added 4 valves and integrated EGR, gaining fleets a 4% fuel efficiency edge. Caterpillar's 3406E hit 600 horsepower with half-degree timing accuracy. Cummins answered with Project Signature, creating the ISX-15. Dual overhead cams, 4 valves per cylinder, 250 bar cylinder pressures, and space for all future emissions tech. Production started in 1998, with initial ratings up to 525 horsepower and EPA 2000 compliance. Fleet switched fast. Longer oil drains, integrated Jake engine brakes, laptop diagnostics. Orders surged as Cummins phased out the N14. Last highway build in 2001. Final industrial unit in 2002. The phase-out was smooth. Exporters packed N14s into containers bound for South America, Russia, and Africa, places where clean air rules were lax. Stateside, Cash for Clunkers programs encouraged fleets to scrap blocks that once ruled the highways. Cummins quietly admitted the venerable cast iron couldn't handle particulate filters without fundamental architecture disturbance. After 57 years of dominance, the king stepped down, not defeated but legislated into legend. Strip today's Class 8 trucks of sensors and plastics, and what remains echoes 1945's design, inline-6 symmetry, turbo breathing, direct injection. The original pressure-time fuel logic, mechanical and cam-driven, reflected the same obsession with timing and pressure that drives today's 40,000 psi electronically controlled common rail systems. Profits from the N-Series built plants worldwide, in Scotland, Brazil, China, India, creating a global network that powers today's X-Series engines. Manufacturing DNA persists. Features like induction-hardened bores, cross-drilled oil galleries, and robust main cap designs trace their roots back to the NH blueprint. The culture echo is loud. Vintage jamborees display Pete 359s with NH 220 tags, smoke crisp as pencil lines. Prairie farmers rebuild NT 855 units to run center pivot irrigation systems. Diesel hot rodders shoehorn big cams into 50s pickups and live-stream quarter-mile pulls at 2,800 RPM. Parts channels never closed. Cummins still catalogs liners and PT injectors. Rebuilders buy cores by the ton. Bedding demand never sleeps. The inline-6 remains the dominant configuration for modern heavy-duty diesels, prized for smoothness and balance, though some V8 and other configurations exist for specialized needs. V8 diesels have waxed and waned in popularity, while two-stroke diesels roared for decades before largely disappearing from on-highway use. But 40-ton freight still trusts the 6-cylinder balance the NH proved unkillable. 7 decades later, that echo isn't nostalgia but a blueprint. Iron proof that when fundamentals are perfect, they ripple through generations of combustion.